Color Computer 3 demos. I decided to make some demos out of some of the tests or stuff I've done over the years to try and experimenting. I thought they didn't end up being long programs. They're just stuff I come up with trying to figure out how stuff works. So I'm going to do different demos, a few of these here. And this first one, demos 1 through 4, are going to be about scrolling. Alright, demo 1 was the first time I've played around and figured out how to use the MMU to do scrolling as opposed to a lot of code to moving stuff around. So we use the MMU. So that was my first test. And then I got that working. Demo number 2, I added a sprite to that. And in fact, I used the same sprite I used in the last lesson, the little window with 4 panes, one of them being transparent. I put it on the screen and got the scrolling doing underneath that window, and you'll be able to see through the window. I got that done. I said, okay, I went on and made another copy, made it a third one. It's animation of a sprite, which is moving the sprite around on the screen. This one here, it was locked in place. This one here is going to be moving the sprite at the same time the scrolling is done underneath the sprite. And number 4, when I decided to do these demos, I cleaned this one up a little bit is all I did. Make not the code, just the presentation better. So I'm not going to be giving you code on this one, but I'll give you a DSK file, and you can run demos 01 through 1, 2, 3, or 4 and execute it. Okay, what I'm going to be scrolling is the text. I started out, I just said, well, I'm going to scroll some text screens. Okay, now these are graphic text screens. Okay, it's not your regular text screen. They're graphic, there's a difference. So the graphic screen can be anything you want it to be. I just happen to want to do it with some text files. It could be any kind of an image you put together in a screen. It could be a maze or landscape, whatever you want. So all I did was take some code, the text out of some programs, just clipped a couple of them, stuck them together, and used that as going to be my text file to display on the screen and scroll it. And that's not all here. I think I used about 50 lines of code. And remember, this is a graphic screen, so you can only get about 40 characters across, so you can't get, we only get one size font out of this. So what I did was, and I didn't want to keep reading a file in because, to read a file in a program, you've got to put all the disk commands in there. I've got copies of that stuff, how you can open a file, read a line, etc., etc. I didn't want to mess with all the code, so what I said, I still want the text. So what I did was, I made a program out of the text file. Made them FCNs, put a quote mark in front, quote mark at the end, start, arg at 1500, and compiled it. So then I can do a load M on it, and then my text file is sitting in there. I print one line, I print the line, and it's got the hex 0 at the end because it's FCN, and it's ready to go to the next line. Just go through all the lines and print them. Let's do a demo. I already have it loaded in, so we'll just do the demo 01. Okay. There's our text file we read in and made graphics out of them, and it's just scrolling through. Nothing exciting, but it is scrolling. That's the MMU doing the work. And that's it. So we'll go back to regular programming here. Okay, let's talk about how we get there. So that same graphics I've been using for a few years now. We're going to be doing this in task 1, which means we'll be using the registers MMU of A8 through AF. our same 64K, and when you normally do task 1, you're going to get 38, 31, 32, 33, 34, up to 35. Okay, we're going to be using the 20 series though. Okay, we're going to use 20 through 24. In fact, we're going to be using 20 through 27. Okay, and this area marked out in here is where all that the text graphics is going to go. I brought in 20. I read each one of them lines in and printed it in here. So that's, I think it was like 30, somewhere around 30 lines it took to fill this up. So we got 30 lines of a text file in here. And you'll see what we need to do is, this is what's going to be displayed on the screen. We're going to tell the MMU to start displaying it block 20, and it displays 3 blocks. This is a 256 by 192 by 16 screen, so it will use 3 blocks to display on the screen. So for just argument's sake, there's approximately 6 lines of that text file are going to be in here, another 6 in here, another 6 in here, another 6 in here, another 6 in here. So in a sense, we'll have 18 lines on the screen. That's close enough. So what we're going to do is scroll this block up. Okay, we're going to just scroll it on up, go right on through. We're not going to stop here. We're just going to go 1 pixel at a time, 1 pixel at a time, up, 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 up. And I just stopped it here in the automation I was doing. So now what we have on the screen is first 6 lines are here, but we're not showing them. We're showing the next 6 lines, the next 6 lines, the next 6 lines. And it just keeps on scrolling, okay? So when we get here, we have this first 12 lines are not, and these 18 lines it's showing are here. Well, we're going to keep on going from there. Okay, we're going to go up, up, and up, and up. Okay, well, we looked at something's here. We got to do something to make this a little different here. So let's move on. Now this here is going to show, back up one here if I can. Okay, this yellow area here, okay, that's from 2000 up to BFFF. That's what runs in between these 2 lines that run all the way across here. That's what that is. That's block 20. What this is going to be what's displayed when we first start out, blocks 20, 21, and 22. Well, I'll stop here. The first thing I did in this here is I cleared out each one of these blocks. I cleared out block 20, block 21, 22, 20, all the way up through 27. How I did that was I cleared 1 block at a time. It was in the program. You'd have a routine. You'd give it the block number and it will clear out 2,000 bytes. You give it another block number to clear out 2,000 bytes. So when we end up here, we got 8 blocks completely cleared out to the background color, which is black or hex zeros. Then I read that text file. I displayed it. Remember, I showed you before, in blocks 20 through 24. So our text file is in here. We tell the MMU to start displaying here. Then we start our scrolling. Okay, we're going to go up 1, up 1, up 1, up 1. Just keep going through. And it doesn't stop here. I just, for display purposes. So again, when we get here, the first 6 lines aren't displayed. The next, these 18 are displayed. So on. We just keep scrolling. We get up here. These 18 are displayed. Now we scroll up again. This first 18 are not, but these 12 are showed on the screen, and block 25 is showed. But remember, I just got to say, I cleared all them blocks out. So now we're going to have part of the black at the bottom of the screen. That's always hard to look at because the bottom of the screen is on top here. And as we keep scrolling, we'll just have the last 6 lines on there and 2 blocks of black. Scroll anymore, we have none of the text on there. We'll have 3 blocks of black on there. So that's all we were doing here, is just trying to show you that as we gradually scroll up, we're moving. And if we didn't have these blocks cleared up here, we'd have whatever garbage was in memory. Okay, so that's kind of what we did. We did it. Oops, I keep going the wrong way here. Anyway, so let's look at some addressing here. Real address in a 512K computer is 00 to hex 7FFF or 512K. It's divided up in 64 blocks of 2,000 each, or 524K. That's 512K. We can address only with 16 bits, or 0 to FFFF, and as you can see, with this FFF, we cannot address that. That's why we got the MMU to tell it what blocks we want to look at in all these 64 blocks. Which 8 do we want to have at any one time to look at? Now, when you do anything graphics, like a graphic screen in BASIC, you do H screen 1, 2, 3, or 4, whatever you do. If you did any one of them, it defaults starting at block 30. Okay, and to tell the MMU, the formula here is whatever block number, hex 30, times hex 2000 divided by 8. And what that means is this is 30 times 6 is 60,000. Hex 60,000 divided by 8 equals hex C000. Now this C00 is not to be confused with this range here. This is just a number that you have passed to the MMU. You're going to store that in FF9D. Sorry, FFD9. Okay, you store that, and what the MMU does magically, well, not magically, he takes this number that you give it, and he's going to multiply it somehow by 8, get this address, and he knows where this stuff is at, so he'll be able to display on the screen. So all you have, because you can't pass him a bigger number, so you just have to pass him this number, and he magically does it. In this example that I've been talking about, we've been using block 20, so I had 20 times 2,000 divided by 8 is 40,000. Hex divided by 8 is 8,000. And that's what I stored in the MMU to tell it where to start to display. Now, if I want to scroll up or down 1 pixel, it's a hex 10. Okay, now the screen we're using is 256 by 192, 16 colors. So each line is 256 bytes. I'm sorry, pixels are 128 bytes. So we're going to put a hex 10 in there. We'd add that to that, make that 8010. We store this here in the MMU, and it's basically we've moved up 1 line. Okay, right there, that is scrolling on Color Computer 3. That's it right there. Add 10 and restore it. Add another 10, restore it, and you're scrolling. I mean, you got other things you need to do, but that's what it takes to do. All right, we'll look at this a little bit more. So if we add 10, we get 8010 hex here. Okay, times 8 is 4080. Okay, that will be in the middle of there, which is what we want. We want to move up each time. So how do we come up with the 10? Right, 10 times 8 is 80, hex 80. Right, in decimal it's 128 bytes. Okay, that's 1 row because we have a 256 pixel screen, 2 pixels per byte, so divide that, we need 128 bytes. So there's how we get to 10. That's how we get to scroll 1 complete line. Now if you're doing H screen 2, which is a 320 pixel screen, you're working this backwards. That's 100, divide that in half, you get 160 bytes for them 320 pixels. Okay, and you can divide that by 8, and it gives you a hex 14. So on H screen 2, instead of 10, you'd use that hex 14, and for adding and subtracting. Okay, now let's go look at all them demos. Now, this is a lot longer than it was supposed to be, but they usually are. Find our Color Computer here. Okay, we're going to run. We already looked at 1, so let's run 2. 2 is where I did the same scroll, and I just added the sprite that's sitting on the screen. Okay, load it in, and you just type in execute. Okay, we're going to see our sprite. Now this one here can be tuned. I didn't worry about that. It needs to be the horizontal sync. Okay, it needs to be synced so it doesn't have the jitter, but it's okay. And as you can see through the window going through there. So that was just a challenge for me to test it. That did work. And all these programs use the same text file, so I don't need to reload it. So I can just do I can just load in the other executable program without running the other part. And this one here is going to have the sprite, but doing some automation in it, okay? Same text file, scrolling underneath the sprite. Okay, we've got our little guy running across the screen now. It looks like he's running downhill, but really he's running straight across the screen. It looks like he's going downhill with the sprite moving underneath him. So again, there's no edge protection or nothing like that. It just goes on there, but trying to, display him and keep him running as the screen's going one way and he's going the other way. It was something I had to figure out what to do. And I'm going to do 4. This one is the one I said I cleaned this. Oops. I cleaned this up, the display up to maybe better presentation. You'll see the same guy running. He's changing colors now. He's going a little faster now. He's red going across the screen until he hits the wall. He hits the wall. He turns blue. The background changes, goes from black and white to white on black. He turns blue to go back the other way. He turns back to red and run across. Again, it looks like he's kind of running downhill, but he's not. It's just the screen's going uphill and behind him. Okay, so he just runs back. I just cleaned it up a little bit. But you have to somewhat think about that, okay? Because as the screen display has been moving up, and that what we did before, we looked at all that stuff. I'll go back here to the other screen, okay? All that's going through here, okay, when the sprite displays, it starts out, he's displaying, I don't remember, somewhere around 3000, hex 3000, okay, oops. Right about in here is where he's displaying when he starts out, right around hex 3000. This is 2000, this is 4. So he's somewhere in the middle, he starts out displaying. Now as the display goes up, okay, if I keep displaying him at 3000, he would stay right down here and never be on the screen. So every time we move up one line, we got to move him up one line also as he's going to the right and left. So every time we go up, we go over with him, or every time we go, so we got to keep him, and he ends up way up here at 8,000. Okay. So anyway, that's just another challenge. Okay, we went through that. Now, I got another test that I'll show you the code. You can have the code on this one. This is a demo 99. Just run it. It's HScreen 2. It's basic, which the default screen will be at C00. All right, and if you want to, like we said before, if you want to scroll one line, you add 14. If you want to subtract, scroll the other way, you subtract the hex 14. Again, no blocks were cleared. Remember I told you had to clear the blocks, otherwise you get junk. Okay, so we'll go back. Going to head back over to basic here, and we will run this is a basic program that's going to draw some stuff on the screen, a circle, and fill it in, and draw a box. This could be anything that you have, any kind of graphics file you have. Like I said, it could be a maze or anything, and then it scrolls up. See the junk at the bottom? The screen we didn't do any clearing for any blocks. Okay, I'll hit the space bar and we'll scroll it back down. I will list it so you can, if you want to use this here, you can type it in. That's all it is. It's just draws a circle, paint, a line, another line, loads in that program, and execute it. Okay, so therefore we're going to run it again. Okay, and you can scroll any graphic screen you've got with this code here. Just I happen just basic was for my test. And again, it will scroll up and scroll down. So just think about it. If you have a maze, you could scroll that screen up and down wherever you want it, or inside of a house, whichever you prefer to do. Okay, and we're going to do one more thing for you here. We'll look at that code for 99, and you can type this in. This is for HScreen 2, 320 by 192 by 16. Okay, here's how we have to do to scroll that stuff. We're going to scroll 50 lines. We'll push that down. There's our default MMU address, which is normal for anything. The screen 2 is. We'll store it in FF9D. Okay, that tells the MMU. It already knows that, but for our loop, we stored in again. And we'll do a delay. Now, if you don't do a delay, it'll go through the screen so fast you won't even see it. Okay, so we got a delay down here. Okay, we do a delay, and then here we're going to add the 14 to what's in D, which was C00. We'll decrement our counter that had 50 in it. If it's not equal to 0, we'll go through the loop. So we're going to sit here and just do this loop 50 times, each time adding hex 14 to it. Just goes through there. When it finally does, it falls through here. We'll push D. We want to save that so we know where we're at on the screen now. We'll go off to basic to get a character, any character from the keyboard. Okay, when you finally hit the keyboard, it's going to fall down here. Put another 50 in the counter. We'll store it. We got to go in 2 off S. Got to remember because we pushed this here, so we got to skip over that. Store that, and then we'll pull D back up. Okay, well, you can't reverse them because we're going to D has our counter, and we'd mess it up with just loading this A. Again, we'll store the D. We'll do the delay. We'll subtract the 14 this time. Nope. I'm going to do the loop 50 times. It basically puts the screen back the way it was, and pull the A and P out and be on our way. I see something different here. This was changed in a later version. It should be a 1F to make it right. Anyway, that's all of it. You see it on the screen. That's right there. You can stop your display, put the basic program in, type this in. This is only hex 37 bytes, or like 55 bytes of code to do that screen display. So I finally think I can say we're done. One more thing I did want to add, if you want to clear a bunch of blocks, here's what I did. You might be able to use this some days. Here's the blocks I wanted to clear, 20 through 27. Okay, go to a routine called clear block. Get down here and we'll find it. Hopefully it's down here. Right there in the middle there. Clear block. Oh, down here. It's got some notes up here. Because you can use this either in task 1 or in task 0. You just have to change these addresses depending on which one you're in. Okay. This comes in. Well, you can see it there. Just so you can copy that code. It brings the block in and goes from 4,000 to 6,000, clears it, goes back, and every time you come in, you just come in with a different block number. So perhaps you can use that someday to clear a bunch of blocks. That's all. Just wanted to add that. Yes. All right. That was longer than I thought it'd be. But anyway, enjoy it. Okay. And I got other demos coming that I've been working on. So, of course, it's springtime now. So I'll get to them. Thanks for watching. Bye.